This video demonstrates through-the-lens camera control. In our interaction testbed, cameras can be dragged like other objects. However, they can also be controlled by directly manipulating the image they produce. We call this through-the-lens camera control. For example, here we manipulate the cameras by controlling where points in the scene appear in the image as seen through the camera. These controls can be maintained as constraints on subsequent manipulations. Through-the-lens controls provide a uniform way for manipulating the position, orientation, and focal length of a camera. Our methods make it easy to define other through-the-lens controls. For example, here we constrain how long the cube edge appears in the image. The constraints also serve as control knobs. Here we tie the apparent cube edge length to a slider. Through-the-lens controls can be combined with world space constraints. The same mechanisms are used. Here, we use a distance constraint between the camera and an object, in addition to through-the-lens controls. Here, we place image position nails on two corners of the middle cube. As the camera is translated along a track above the arrows, it pans, zooms, and rotates to maintain the positions of these points. Inequality constraints allow us to restrict through-the-lens controls. For example, here we bound the position of a point inside of a rectangle. The through-the-lens controls can also be made to follow along motion paths. Here, 4 motion paths are used to specify a camera movement. Each arrow is connected to a corner of the cube. So far, we have only considered stationary objects. By coupling object and camera motions, through-the-lens controls can implement behaviors like tracking, shown here. With the camera held in place, through-the-lens controls can be used to position objects. In this example, through-the-lens controls are used to place the spacecraft as well as position the camera. The positions of the planets are fixed, while the camera and spacecraft are free to move. In this example, we superimpose our image on top of video. The rectangle has the same dimensions as the table. By positioning the corners so they coincide with the table, the camera location can be recovered. This permits registering our 3D model with the video image.